Out in the constellation Cygnus, thousands of light years from home, there is a genuine cosmic mystery. It's an object with a kind of funny name, the Egg Nebula, but it is absolutely stunningly complex. And today, we're going to try and crack this case wide open.
Thanks to incredible instruments like the Hubble Space Telescope, we have these just breathtaking images of this thing. Its official name, by the way, is CRL 2688, and it's become a bit of a cosmic celebrity, really, famous not just for its out-of-this-world beauty, but for the deep, deep secrets it's holding.
But let's talk about that name, the Egg Nebula. For a structure this spectacular, the name feels a little underwhelming, doesn't it? Well, it actually comes from a paper way back in 1975, where the author, E.P. Ney, even admitted to using some artistic license. So what on earth was he seeing that made him think of an egg? Well, here's the thing. Back in the 70s, telescopes could only see this blurry, two-lobed blob. And yeah, if you kind of squint and use your imagination, it vaguely looks like a cracked egg. But what we see today with Hubble, whoa. It's an intricate masterpiece of cosmic architecture. It's pretty clear those early astronomers had no idea what they were really looking at.
Okay, so now we get why it has such a quirky name. But honestly, that just opens up a much bigger, more important question. What is this thing? I mean, what kind of cosmic process could possibly create something so bizarre and so beautifully complex?
To really understand the Egg Nebula, we first have to understand where it comes from. And here's the twist. We're not looking at the birth of stars here. We're actually looking at the dramatic final moments of one.
The Egg Nebula is what astronomers call a proto-planetary nebula, or PPN for short. Now, please don't let that name fool you. It has absolutely nothing to do with planets. This is the final fleeting gasp of a dying star. It's a phase that lasts only about 1,000 years, a blink of an eye in cosmic time, right before it becomes a glowing planetary nebula.
So we're catching this star at such a critical moment. It's already puffed off its outer layers into space. And now its super hot core is starting to light all that material up, creating this incredible, incredible light show. What we're seeing is a snapshot of a violent but truly beautiful transition.
All right, so to solve this mystery, we've got to dissect the evidence. Let's perform a little cosmic autopsy, shall we? Our first clue is a missing person, or, well, a missing star. Right at the heart of this whole structure, there's an F5 IS supergiant, but we can't see it, not directly. It's completely hidden from view. So, what's hiding it?
The culprit? A thick, dark lane of dust. This dense disk is wrapped around the star's equator like a shroud, and it's trapping the star's light, preventing it from escaping sideways. But all that trapped starlight has to go somewhere, right? It ends up bursting out from the star's poles, erupting into these unbelievable intersecting beams that look just like giant cosmic searchlights piercing through the dark. So let's break down the full anatomy here. We've got the hidden star, that choking dust disk, the bright lobes where light can escape, those super sharp searchlight beams. And if you look really close, you can see these faint concentric arcs. These are amazing. They're like tree rings, showing the history of the star puffing off its layers over thousands of years. But what's actually carving this incredible shape? What's punching holes in all that dust to create those searchlights in the first place? Well, all the evidence points to something incredibly powerful: jets. Radio telescopes let us see what visible light can't, and they see this really distinct S shape in the gas. That's the smoking gun, the telltale signature of a jet that's wobbling, or precessing as it spins. They also detect these finger-shaped outflows of gas, just blasting away from the center at incredible speeds. So these high-speed jets, they are the cosmic sculptors here. They are blasting out from that central star, punching holes in the dusty shroud around it. They carve out the very cavities that let the star's light finally escape and form those spectacular searchlight beams we see. So, we have the star, we have the dust, we have the jets. Case closed, right? Well, not quite. The Egg Nebula, it turns out, still has plenty of secrets left. For starters, astronomers can't even agree on how far away this thing is. Estimates range all over the place, from just over 1,000 light years to more than 3,000. I mean, that huge uncertainty makes it really hard to figure out basic things, like its true size or how bright it really is. And then there's the chemistry, which is just astoundingly complex.
Scientists have detected 38 different types of molecules in the gas floating around. But here's the real kicker. The sheer amount of some of them completely breaks our current models of chemistry. Something else is going on in there.
So what could cause these powerful wobbling jets, the ridiculously complex shape, and the bizarre chemistry? Well, the leading theory points to a hidden culprit, a companion star, a secret partner orbiting the main star, whose gravitational pull is stirring everything up, launching the jets and shaping this entire cosmic masterpiece. The Egg Nebula is really a stunning reminder that even in death, a star can hold a universe of mysteries.